Objective 3 in part 2 of Module 3 is solving using the quadratic formula. So solving quadratic functions with the quadratic formula is your objective. The quadratic formula exists here. And it is very important to get very familiar with this formula. We'll be using it a lot. We find the solutions of x. So again, if they're real solutions, they will cross the x-axis. They can be imaginary solutions and they can be irrational solutions. Those are the three options. And this formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, will help us find two solutions, typically, unless special cases occur. Now, this formula is all based off of, so please write this down, again, standard form. Standard form of a quadratic, where it's ax squared plus bx plus c. If you recognize there's a b, a, c, and a. They're all based off of the a value, the b value, the c value. So if you notice in the first step of using the quadratic formula to solve, we'll put it first in standard form, so we'll talk about that. And then number 2 is identify the values for a, b, and c, something you've been doing for solving with factoring and solving using the square root method. Now, the quadratic formula, what's special about this is I've noted here is that you can use the quadratic formula when solving by factoring isn't an option, and also when solving by taking the square root isn't an option. It's important to consider solving by factoring is much easier than using the quadratic formula, but it's not always an option, and also solving by taking the square root is typically easier than using the quadratic formula, but again, it's not always an option. So when in doubt, on a test or on a quiz, you can always use this quadratic formula to solve a quadratic function. You just have to be very careful, because if you notice, and I'm going to erase this eventually, but there's a lot of different, you have to be very careful with your signs, and there's 1, 2, 3, 4, 5 places where you have to input numbers. And if the numbers are negative, then you have to be very careful and remember to put negative numbers in parentheses whenever you insert them into a function. So just consider that as you're working with this formula. This formula can be very, very beneficial to you, because if you get really good at this, which you need to be able to begin to master this, you will be able to solve any quadratic formula using this. I would always check, before you use this, I would always check though if you can factor it using MACAB or finding the greatest common factor, or if you can solve by taking the square root, just because those are a little bit quicker and easier to work with. But again, when in doubt, the quadratic formula. I'm going to model with number 1, this example, exactly how I want you to do the quadratic formula, or use it to solve for the solutions of a quadratic function. Okay, so I've listed the steps out here on the right. And if I was going to analyze this problem, I see the quadratic term, 2p squared, the linear term, 3p, and then the only thing that's different here is we've been dealing with functions that equal 0 on the right-hand side. This doesn't equal 0, it equals 20. So my c term, 20, isn't in the place that it needs to be. If I set this equal to 0, the first step is put equation in standard form. The first step then is to make it look exactly like it does up here, where my a term is first, my b term is second, my c term is third, and then they all equal 0. So in order to do that, what jumps out at me again is that there's a number on the right-hand side. It needs to be 0. It needs to equal 0 on the right-hand side. It doesn't do that. Right or left-hand side, but in this case, the right-hand side. So in order to do that, it's a positive 20 on the right-hand side. I need to subtract it to both from this side to cancel it out on that side, and then to this side. Now, a lot of times people get confused, like there's nothing to subtract 20 with on the left-hand side. That's good. That just means that it becomes my c term at the end of the standard form of the quadratic. So I'm going to rewrite it. So step 1, put it in standard form. It now becomes 2p squared plus 3p minus 20. It cancels out on this side, so it all equals, when it cancels out and there's nothing left, it equals 0. So I have done step 1. I put it in standard form. Now, Step 2, please get in the habit of writing this out every time, just so you don't make any mistakes. You have to be very particular about your negatives. Step 2 is identify the values for A, B, and C. So my A, again, this is, I'll do it in a different color. A, my B term, and my C term. So my A term is 2. My B term is a positive 3. And my C term, I'm going to just save room. I'm going to write them this way. A term is 2, B term is 3, and my C term is a negative 20. Be very particular that you include the negative 20. If it's a minus the number or minus the term, then it has to be negative when you list out your values. So I did step 2, done. Step 3 is to put the values into the quadratic formula. Now again, if you're entering a negative number into the quadratic formula, please put it in parentheses, always, always, always. Now the way I look at it, this is a negative b, right? It's always, whatever the b term, it's opposite that, okay? Just keep that in mind. So whatever the b term is, it's going to be opposite of whatever it is. So in this case, my b term is a positive 3. So in the formula, it needs to be a negative 3, plus or minus the square root of my b term, which I'm going to put in parentheses regardless because I'm squaring it. My b term is positive. Remember, the first piece is opposite the sign just because the default quadratic function starts out being negative or opposite. So it's the opposite b to start with, then plus or minus the regular b squared, minus 4, parenthesis, my a term, which is 2, and my c term, which is negative 20. And this is all over 2 times a, which is 2. If you notice too, another jumping off point that I didn't mention is the quadratic term right here is 2. We've only been able to factor quadratic terms when the leading coefficient is 1, or it's just the letter p squared without a number in front of it. That should be another clue to where it's like, I don't know if I can factor this, but I can definitely use the quadratic formula. Alright, let's continue step by step. So, I have put the values into the formula. I'm done with step 3. Step 4 then, and I put this use PEMDAS to solve formula, go step by step. What I really want you to do is, and I'm going to change this, we need to simplify what's underneath the radical first. I highlighted in green. This is called the discriminant. Please make note of that, and we're going to work with that in Objective 4, actually. But the first step always is to simplify what's underneath the radical called the discriminant. So I'm going to change this step on your note sheet so it'll look a little different. So this should be simplify discriminant. So if I were to do that, I would get, if I put 3 squared minus 4 parenthesis 2 parenthesis negative 20 into my calculator, exactly like that. So I'm just doing the underneath. Don't include the radical when you put that in your calculator. I should get then the square root of 169. So please be following along and using your calculator and make sure you get the square root of 169. If you don't, please raise your hand. Don't use the radical on your calculator yet. Just do the numbers underneath and enter it exactly like you see, exactly like I wrote it. Now, after I do that, the first step was to simplify the discriminant. Then I'm going to rewrite everything. So I have negative 3 plus or minus. This is tedious, but you need to do this. You need to be very careful as you work. 169. Again, this simplified to 169, and it's all over. I can do 2 times 2, which is 4. Now, so step 4 is to simplify and then rewrite. Step 5, so I just did step 4. Step 5 is simplify the radical if necessary. And again, the first step I always want you to consider is the number underneath the radical a perfect square? Sometimes the number will be, sometimes it won't be, sometimes it'll be a negative, so it'll lead to imaginary solutions. This is where this process it'll look a little different than this example for some problems that you practice on. So if you can get to step 4, this could be a very good checkoff point for you. If you can get here and have at least simplifying the discriminant to where it's now a number, not 4 numbers, that's a great checkpoint for you. And then we can work on it as you practice. But I will take the square root of 169 on my calculator, and it turns out that it is indeed a perfect square. So step 5 is I'm going to rewrite it one more time, but I'm going to simplify the square root of 169. And in this case, the square root of 169 is 13. So I write negative 3 plus or minus 13 all over 4. Now, sometimes it won't be a perfect square, so that's where you're going to have to do your factor tree and simplify the radical as far as possible. And I'm going to do examples number 2 and number 3 will look different than the one that I'm doing right now. At this point, if you notice, whenever this is the case, so please make note of this, whenever this is the case, I have a whole number here, a whole number here, and a whole number there. All right? Sometimes you can reduce all the numbers, they can all be divisible by a certain number. This isn't the case here. But whenever they're whole numbers, I can actually do this math. There's 2 pathways. It'll be, so this is step 6, simplify the expression if necessary. I'm going to do negative 3, the positive version, so plus 13 equals 10, and then divided by 4. So that equals 5 halves. So one of my solutions is 5 halves. And then I'm going to do negative 3 minus the other pathway, the positive version and the negative version. So minus 13, which equals negative 16 divided by 4. And that equals negative 4. So my 2 solutions, I'll put them right here. X equals 5 halves and negative 4. Please square in your final answers. So there will be times when you practice these problems, there's 10 of them for you to do, where at the end, step 5, if you write out step by step what you need to do, it will be all whole numbers. If they're all whole numbers, then you can do 2 pathways, the positive version and the negative version, and you get 2 solutions. At times they won't be all whole numbers, and at times they'll be imaginary solutions at this step. And that's what I'm going to show you in other videos in problem 2 and problem 3. I understand this is very tedious, but if you do this correctly and you get really good at doing this and solving with the quadratic formula, you could master this solving quadratic functions and do really well on the test. And I want all of you to get there. So look for the next 2 videos where I do example 2 and example 3.